Hello everyone, I'm Mr. Furlong, and today we're talking atomic stability. We're going to be looking at how atoms forms bonds in this chapter. And one thing we have to take note of is that atoms always want to have a neutral charge. So in other words, they always want to have an equal number of protons and electrons. That will make them electrically neutral. That's what makes them stable. Or as I like to say, it makes them happy. And so how they do this is by combining with other atoms. And when that happens, we can take these very unstable elements and make them very stable compounds. But there's a certain rule that is always followed when atoms combine. And this is known as the Octet Rule. The beginning of that word, oct, might sound familiar, like an octopus. They have 8 tentacles. Or an octagon has 8 sides. The Octet Rule says that atoms will always combine in such a way so that they'll have 8 electrons in its outer shell. And so we're talking about the electron shell. They always want to have those 8 electrons. That's what makes it a complete shell. And when they have a complete shell, they're going to be happy atoms. So for instance, we were drawing atoms earlier. And if we look at sodium, for instance, we see that sodium has 2 electrons on the first shell. It has a total of 2, 4, 6, 8 electrons on the second shell, but it only has 1 electron on that outer shell. That makes sodium not very happy. In other words, it makes it very reactive. Fluorine, on the other hand, has 2 electrons on the first shell. It has 2, 4, 6, 7 electrons on its outer shell. It needs 8 to be happy. It needs 1 more. So you can see what sort of happens here is that sodium is looking to maybe get rid of that 1 electron. If it does, it'll have 8 electrons on its outer shell. Fluorine is looking to maybe gain 1 more. If it does, it'll have 8 electrons on its outer shell and it'll be complete. Then it's going to be happy. And everyone's happy then. And so this is what happens in nature. What we find is that when bonds are formed, only the electrons in the outer shell are involved in those chemical reactions. And we call these electrons the valence electrons. The only valence electrons that an atom has are the ones found on the outer shell of that atom. So for instance, here's the atomic structure of phosphorus. It has 1, 2, 3, 4, 5 electrons in its outer shell, which means that it has 5 valence electrons. Neon has 1, 2, 3, 4, 5, 6, 7, 8 electrons in its outer shell, which of course then means that it has 8 valence electrons. Rubidium, with all those electrons, still only has just 1 electron in its outer shell, so it only has 1 valence electrons. Now remember, that's all we really need to know when atoms are going to form bonds, is how many are in the outer shell. So there's a shorthand way of writing this. Instead of writing out all of these electrons like we have here, we can do what's called the Lewis dot formula. So let me give you a few examples of this, and we're going to practice making some of these. Let's take a look at phosphorus, for instance. We need to know what family it's in. Now remember, we labeled these on our periodic table already. We have family 1A, 2A, all the way through 8A. Phosphorus is in family 5A. So every element in family 5A has 5 valence electrons. So how do we show this? Well, let's pretend like we're putting an invisible square around that symbol. And we're going to use dots to represent these valence electrons. It has 5. So I'm going to start by putting a dot on the top of that square. I'm going to put the second one off to the side, a third one on the bottom, and a fourth one off to the side, and then of course it has a fifth one. That is the Lewis dot formula for phosphorus, because all we need to know is that it has 5 valence electrons. Let's take a look at neon. Neon is in group 8A. So again, we simply make an imaginary box around our symbol, and we start on the top. We go, there's 1, 2, 3, 4, 5, 6, 7, 8. So this is what is said to be a complete outer shell. It has all 8 electrons. Remember the octet rule. All atoms want to have 8 electrons in that outer shell. Because all the elements in family 8A have 8 electrons in the outer shell, they're all full. They're happy. That's why they're called the noble gases. They don't react with anybody. So let's take a look at one more. How about rubidium? Remember, this is that real big one that we saw. It's in group 1A. So again, we have this imaginary box around rubidium, around the symbol, and we draw 1. Oh, that's it. That's all it has. So we can get a lot of information about this. We'll talk more about how these electrons are used in forming bonds in a future video. We're going to spend some time in class practicing how to write these Lewis dot formulas. And I'll see you then.